Hello, this is the third video of polynomial functions, and today we will learn a little bit more about solving polynomial functions, which is a synonym to saying that we will find the roots or the zeros of it. So first, let's see how to find the number of positive real zeros that a polynomial has. So we do this by finding the number of sign changes. What do I mean by sign changes? Well, if you had, for example, x to the fifth minus x to the fourth, then we see that here we have one sign change, which is from positive to negative, right here, see? So that means that we have one positive real zero. And we will learn actually how to factor this out, and we will find that in fact we have only one positive real zero for this function. So for example, if we had x, like we had before, x squared plus 4, we find that there is no sign change here. We have a positive here and a positive here, so there's zero sign change. So there are zero positive real zeros. So even though this kind of shortcut doesn't say anything about the total amount of zeros, we know that this function doesn't have any positive real zeros. And by looking at the graph, we actually find that it has no zeros at all. But so with this shortcut, we can only say something about the amount of positive real zeros. And now we will look at another kind of shortcut or theorem. Okay, so the rational zeros theorem states that if you have a polynomial, we will call this p of x, that has integer coefficients, so that means that all the coefficients are integers. And if you have a zero, that is p over q, so that you have maybe 4 over 5 or 1, which can be translated to 10 over 10, 20 over 20, and things like that, then p is a factor of the constant term. So the constant term is just the one that has no x. And q is a factor of the leading coefficient, and we learned that the leading coefficient is the coefficient of the term with the greatest exponent. So, for example, if we had, x squared minus 4, we found that the zeros were 2 and negative 2. So let's see if our rational zeros theorem says that 2 and negative 2 are rational zeros to this to this polynomial. So we find that the constant term is negative 4. And so the factors of negative 4 are 1, negative 1, 2, negative 2, 4, and negative 4. And then we also have the leading coefficient, in this case 1, and so the factors of 1 is just 1. So now we see that a zero is p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. So we see that our zeros are 2 and negative 2, and we know that 2 can just be represented as 2 over 1, and negative 2 can be represented by negative 2 over 1. So by having this, we see that 2 is actually in our list of the factors of the constant term, right here 2, and 1 is the only factor of the leading coefficient. So this is a rational 0. And same thing for negative 2. We have negative 2 in the list of the factors for the constant term, and of course we have the 1 for the leading coefficient. So the rational zeros theorem tells you if a 0 is rational or not, if a 0 could be a 0 for the polynomial or not, but it doesn't necessarily tell you which are the zeros unless you apply it in a certain way, which we will learn in the next video.